Okay. Good morning, all. Dear audience, dear speakers, welcome to today's session on funding opportunities for the development of carbon capture and utilization. This is a joint webinar organized by CO2 Value Europe, the European Association for representing the CCU community, to European projects, VIVALDI, and initiate VIVALDI, treating biogenic emissions for the production of chemicals, and initiate the valorization of steel-making off-gases, and also Synergy, the EU-wide initiative for solar fuels and chemicals. So today we will be looking at some funding instruments for CCU. We will start with a small introduction on Horizon Europe and some CCU relevant topics. This will be done by myself. I'm Anastasios Perimenis, Secretary General, CO2 Value Europe, and Frédéric Chandezon, Deputy Coordinator of the Synergy Initiative. We will then go to some case studies of Horizon Europe projects with VIVALDI and Initiate, so that you can have an idea of what it means to have a research and innovation action and to work on a research and innovation action, and what it means to work on an innovation action. And you will hear from Mira Sulonen from the Autonomous University of Barcelona and Eric van Dijk from TNO, respectively. We will continue with Horizon Europe, but another section of Horizon Europe, the European Innovation Council, and we will hear by Francesco Matteucci from the European Innovation Council and SME's Executive Agency. And then we will expand into the Innovation Fund, one of the largest clean tech funds in the world, and another instrument, a little bit different, but still very relevant for CCU, the Breakthrough Energy Catalyst, from the cooperation of the Breakthrough Energy Ventures and the European Commission. So if you have any questions, please put them on the chat or the Q&A. After each presentations, we will open the floor for Q&A and exchange. The video is recorded. It will be made available after the webinar, so will be the presentations. So without further ado, let's go directly into the first part of today's webinar and talk about a little bit about Horizon Europe. So we'll do that together with CO2 Value Europe and Synergy. And just before starting directly on Horizon Europe, and for those who are not familiar with the subject, why we are here today, what is CCU and why it is important. It's because we we turn a problem into a solution. We turn CO2 emissions into a solution by capturing these emissions either from flue gas, from industrial installations, or directly from the air, with often renewable energy, and transform it through an array of technologies into a series of marketable products. Can be fuels, can be chemicals, can be materials, for example, for the construction. So in this circular process, we reduce emissions. We might even arrive to carbon removals and negative emissions, depending on the CCU pathway. For example, direct air capture and mineralization to a permanent sequestration into a carbonate can be considered carbon removal. Importantly, we provide an alternative carbon feedstock. There are not many alternatives for fossil carbon, and we still need carbon in our products. So CO2 can be a scalable carbon feedstock. We increase circularity by reusing emissions into the production system. And some of the inputs that we are also using are residues from industrial activities, for example, for the case of mineralization. So there's also an element of waste management and a double circularity. So this way we make our industries more resilient to fluctuation, for example, of fossil resources, and we also introduce more renewable energy into the system, into the industrial system, into the transport system, and we can store and transport renewable electricity in an easier way. So in a nutshell, this is why we're working on CCU, and this is why it is important to have funding instruments that are supportive of CCU technologies. CO2 Value Europe is the European association representing the CCU community, bringing together stakeholders from the complete valorization, so from the upstream of capturing carbon, transforming it into products, and the downstream distribution of the product. So we have a very diverse membership base with multinational companies, technology providers that convert CO2, clusters of industrial activities at different regions, research institutions, and universities. And what we're trying to do is a three faceted approach. First, collect intelligence on CCU technology, who does what are the projects that are ongoing, who is behind them, what kind of technologies they're using. Collect scientific information like life cycle assessments, techno-economic assessments to prove the potential of CCU. We also bring together our partners to help upscale these technologies, to innovate on those technologies. We participate ourselves in EU-funded projects, but we also help stakeholders to access EU public and private funding. This webinar is one example of the activities that we're doing. And of course, we are analyzing the policy context. It is a very dense policy period, energy and climate-wise, and we are making sure that the regulatory framework is as supportive as possible and as consistent as possible. And of course, we communicate about CCU, about its merits, about its limitations, to increase public awareness about the potential of CCU to contribute to climate change mitigation. We have partners in this journey. One of them is Synergy, the EU-wide initiative on solar fuels and chemicals, and I would gladly invite Frédéric Chandezon from CEA and Deputy Coordinator of Synergy to say a couple of words on Synergy also.
Okay, thank you, Anastasios. Can you hear me well? That's okay?
We can hear you, yes.
Yeah, perfect. Thanks, Anastasios. I mean, you already said the frame and the landscape, so not sure I have a lot more to say. Well, I mean, yeah, as pointed by Anastasios, Synergy is indeed an initiative, EU initiative, focusing on renewable fuels and chemicals, with a lot of focus on solar energy. So with the vision, which is summarized in the schematics that you see below. So we want to find alternatives to, well, we want to have fossil-free fuels and chemicals using renewable solar and power and solar energy and simple feedstock molecules that we can find either in the environment or as a waste of human and industrial activities. So that's what's summarized in the red rectangle and also in the schematics on the left. So this is the feedstock, on the right these are the products. And the idea, it deals with storage of renewable energy, solar energy, okay? So some things which you can, well, that's going a step further when you think of, for example, solar of renewable power, where you go to the power, but you have to solve the problem of storage. So chemical energy storage is one focused. Okay, we want to have also, beside fuels, there's also the point of handling chemicals for industry and agriculture, and the building blocks of the chemical industry, which are currently based on fossil resources, so highly dependent on EU external resources, and also development of technology with a neutral or CO2 footprint. Okay, so of course there's a lot of, you can see the cycle that Anastasios showed as well. That's also, I mean, it's also the idea. Recycling, I mean, transforming this feedstock into products that can generate a service and waste that can be put back into the loop. And of course, it has a lot of connection with CCU, thus our partnering between Synergy and CO2 Value Europe, plus also looking at some closing the nitrogen cycle as well. Okay, so next slide, please. So this was Anastasios?
Yes, I'm doing it now. Yes.
Okay. So in terms of in practice, so Synergy is a rather young initiative. It comes from two former initiatives where the focus was on chemical energy storage. I won't go into that into detail on that. And which merged in this in Synergy. The official launch was 2 years ago, and we have been advocating for towards the community, towards member states and European Commission to promote this activity on this large-scale coordinated action and initiative at the EU scale around us fossil-free fuels and chemicals. With the following objective in terms of timeline, we think there is a need of a large-scale initiative, public, it could be, for example, public-private partnership, something to agree with Commission and the member states. And in terms to, in view of implementing that, we are currently in a so-called ramp-up phase, where besides coordination and community building, road mapping, we have a road mapping workshop in mid-June. I guess the information was spread through different channels, maybe also through CVE. We can always disseminate that. So besides community and road mapping, there's also implementing the Synergy roadmap. And this is done with a portfolio of relevant projects, and some action of coordination acting as a glue, so coordination and support action. And in fact, we were recently granted as Synergy, a Synergy-based consortium was recently granted a project which is expected to be launched in the coming months. Okay, Synergy. So which will be exactly as an aid to deal all those aspects of the ramp-up phase that I mentioned, plus prepare the path of the large-scale European initiative. What is not mentioned there is that we also have a focus of connecting, besides addressing police and strategy and European agendas, we also work with national member states on these aspects, and have also action at the international level with the International Energy Agency or within Mission Innovation. Okay, and could you click again, Anastasios? Yeah, so the current organization is that, so they is coordinated by Bert Vekusen from Utrecht University. I'm CA's co-deputy coordinator, I'm taking care of that. And well, we have an executive board with core partners from academia, RTOs, industry and society, and a large community whose aim is to strengthen it. Okay, so either with academia, industry, civil society, government, local, and network. And that's why we also have strong links and connections with CVE. Okay, so just to summarize, the idea is really to make some inclusive action and activity around those topics, okay, and to be the voice of the community, to work with the community, to be the voice of the community with European Commission member states, and that's exactly that's what it's all about. So now I hope we can meet during the road mapping workshop. I mean, we have we have the road mapping workshop of Synergy, and afterwards CVE. So I hope we have occasions to meet and discuss on all this. And that's it. Thanks.
Thank you, Frédéric. We will talk a little bit about Horizon Europe, specifically about the second pillar on global challenges and European industrial competitiveness. Horizon Europe is the largest instrument for financing R&I in Europe. Around 96 billion euro will flow into Horizon Europe. It is especially for the second pillar, the clusters that are of most, let's say, relevance for CCU are the ones, the fourth cluster on digital, industry and space, the fifth one on climate, energy and mobility, and the sixth one on food, bioeconomy, natural resources, agriculture and environment. Later on, we will also hear about the European Innovation Council, but that for the moment I leave it aside because you will hear directly from Francesco about this. So those who were following us, you might remember that last year, more or less at the same period, it was around April, we had another funding workshop with co-organized with Synergy, and there we presented all the relevant topics on CCU from the work program of 2021-2022. It was a booklet, a small booklet that gathered everything, all information to guide stakeholders into applying for this. So a lot of calls, there were around 35 relevant topics. A lot of them are still ongoing. If you look at the middle of your screen, for example, the one on renewable energy carriers from variable renewable electricity surplus and carbon emissions from energy consuming sectors, a very typical, I would say, CCU project that is opening next week, and it will be open until October. It's an innovation action, and with a considerable budget. 2 projects are expected to be funded by it. So all this information and all these topics are available under the funding and tender opportunities platform, and you can find all the necessary information to apply there. The point being that following Horizon 2020, we had around more than 90 projects that were CCU related, so not necessarily specifically and only on CCU, but CCU related. And around 650 million euros went into those projects from Horizon 2020. The successor of Horizon Europe follows this trend in 2021-2022 with around 35 topics and some hundreds of millions of euros dedicated to them. So it is a trend that we see that is consistent, and although we don't know yet a lot of details about the work program of 2023 and 2024, from what we are able to gather, this trend continues. So we will see topics appearing in the work program of 2023 and 2024 for considering CO2 and CO from process industries as a chemical feedstock, for example, or the continuation of the notion of hubs for circularity and industrial symbiosis that we see in the partnership of processes for planets. Projects and topics that link to CCU fuels or synthetic renewable fuels or solar fuels, the capture and reuse of biogenic gases, the development of a CO2 transport infrastructure, not only for utilization, of course, but for storage. Topics on carbon removals and negative emissions that will touch upon, for example, direct air capture and mineralization, but also specific use of CO2 in the built environment for materials. So we expect these topics to appear in the coming years. Unfortunately, we don't know much about this yet, but what we will do is normally after the summer, we will have more information and more clarity on the work programs, and we will create the same type of booklet that will be, let's say, the basis for all interested stakeholders to see what kind of funding opportunities Horizon Europe and the new work programs can offer. So that's it basically for this first session.
Anastasios.
Yes, please, Frederick.
Can I add make one comment? I would say on those, so it's really, I mean, as Anastasios said, there should be further opportunities, and we can tell more later after summer. What I would also like to mention, you know, we will have these topics, regarding these topics, CVE, Synergy can be consulted based on their roadmaps. So it's really to provide some suggestions, accepted or not, but that can be used as input, just as an element for such topics. So I really invite, I think it's really important to commonly build those roadmaps and those aspects which can contribute to the European agenda. So that was just to complement what you said, Anastasios. Okay.
Yes. Thank you, Frederic. Thank you. So if you have any questions on that part, feel free to put it on the chat or the Q&A. We will answer it during the conference. What I would like to do now is go to the practical side of this session and hear from projects. So hear about what EU funding can do and how it is important to have consistent funding for research and innovation projects. So we will start with VIVALDI, the Research and Innovation Action, and Mira Sulonen, the scientific manager of VIVALDI, is here with us to explain more about the project. Mira, the floor is yours.
Hello and good morning. My name is Mira Sulonen and I'm from the Autonomous University of Barcelona. And as Anastasios mentioned, I'm the scientific manager of the project VIVALDI, which stands for Innovative Bio-based Chains for CO2 Valorization as Added Value Organic Acids. That means that we are turning CO2 emissions into sustainable bioproducts. And this 4-year project started in June 2021, so we are 1 year in. And the consortium consists of 16 partners from across Europe. The VIVALDI is a research and innovation action funded by European Union under the program Developing Integrated Biorefineries, and the topic bio-based industries leading the way in turning carbon dioxide emissions into chemicals. The total funding that was awarded to us was just about 7 million euros. The VIVALDI's research is driven by the need for novel carbon capture and utilization strategies for CO2 valorization. In addition to the reduction and mitigation of industrial CO2 emissions, they can also be adopted as novel feedstocks, which bring us to the era of CO2-based chemicals. This is also encouraging industries to abandon the conventional linear structure where fossil-based reagents are transferred into products, while generating wastes that need to be disposed or treated, and switch to a circular concept where these so-called waste streams are transformed into novel sustainable compounds that the industries can utilize themselves or sell to other industries. In addition, the replacement of fossil-based compounds with bio-based products can lead to significant decrease of greenhouse gas emissions. Therefore, this innovative, sustainable, and cost-efficient biotechnical solution that VIVALDI is developing to convert off-gas emissions of bio-based industries into CO2-based chemicals will allow the biorefineries to reduce their greenhouse gas emissions, to reuse the CO2 emissions as a novel feedstock, to lower their dependency on fossil fuel imports, and also to lower the exploitation of key resources. VIVALDI is proposing an integrated solution for the conversion of biogenic CO2 into 4 selected added value organic acids, which can then re-enter the production process of the biorefineries. First, the captured CO2 is converted to methanol or formic acid, which can serve as a feedstock for the bioproduction of the industrially relevant organic acids. nutrients required in the bioproduction are recovered from industrial wastewaters. And after downstream processing, the products will be industrially evaluated to ensure that they meet requirements of the end users. The focus in VIVALDI is on real gas emissions from 4 key bio-based industries, including pulp and paper, food and beverages, biofuels, and biomaterials. The captured and purified CO2 will be first reduced electrochemically to formic acid or to methanol using innovative electrochemical reactors and gas diffusion electrodes. Nutrients that are needed for the bioproduction of the organic acids, like ammonia, potassium, and calcium, are recovered from industrial wastewaters using bioelectrochemical systems. The bioproduction itself is done using an engineered strains of yeast, Pichia pastoris, and the methanol and the formic acid and CO2 from the step 1 are used as a feedstock for the fermentation, and the nutrients recovered from the wastewaters in step 2 will be provided to support the microbial growth. Custom-made downstream processing techniques are used to ensure that the products meet the required standards, and to confirm this, the bioproduced organic acids will be also industrially validated. In addition to allowing the conversion of CO2 to added value chemicals, the main advantages of electrocatalysis in the CO2 transformation are that the CO2 can be reduced to different products by altering the conditions and the electrode materials, and that the reactions can take place in biocompatible conditions, such as neutral pH, ambient temperature, and pressure, which makes it easier to integrate the CO2 transformation to the bioprocesses. The electricity required for the electrochemical reduction of CO2 can be obtained, for example, from photovoltaic cells, wind turbines, or from off-grid grid power sources. And the products actually also provide a method for temporary storage of the energy. In VIVALDI, the target compounds were chosen to be formic acid and methanol, as they both are efficient substrate for the fermentation. For example, the energetic efficiency of converting formic acid and methanol into biomass in aerobic conditions can reach 50%, while for other CO1 feedstock, the efficiency has been observed to lie in the range of 20 to 40%. And with C1 gases such as methane, the storage and the transportation can be problematic, and the low solubility and limited mass transfer often lower the productivity. Currently, significant amount of money and resources is spent for the removal of nutrients from wastewaters, as eutrophication can cause significant damage to the environment. In VIVALDI, we are recovering these nutrients with bioelectrochemical systems. And that is working because certain bacteria are able to convert the chemical energy stored in the organic contaminants in the wastewater into electrical energy. And the generated current can be used to recover ions such as ammonia, potassium, or calcium from the same water streams. The wastewater is also simultaneously treated as the organic contaminants are removed, and the recovered nutrients can then be utilized in the fermentation. The biochemical nutrient recovery allows companies to abandon, again, the linear economic models, and it provides significant environmental, economic, and energy savings. Pichia pastoris was selected for the fermentation as it can grow at the optimal conditions for the recovery of free organic acids, which means low extracellular pH, and they can also grow at high product concentration. It can also grow solely on methanol, and it can use formic acid as an auxiliary substrate. The media can be relatively simple, and with Pichia, industrial scale fermentation, as well as genome scale metabolic models and synthetic biology tools have already been established. We are focusing on the bioproduction of 4 industrially relevant organic acids, which are 3-hydroxypropionic acid, lactic acid, succinic acid, and itaconic acids. These assets have different applications and market penetration, but they all have been identified as top future value platform chemicals. All 4 of them have a lot of opportunities, either as standalone products or as monomers in production of novel biodegradable polymers. In VIVALDI, we aim to provide bio-based industries a solution for converting their CO2 emissions to compounds that can re-enter again their production process flowchart. And that is why we have companies in our consortium that have interest in these selected products. CO2 enrichment is currently at TRL 5, but electrocatalytic CO2 reduction, biochemical ammonia recovery, and the production of the selected organic acids via Pichia-Pasteur's fermentation are still at TRL 3. And VIVALDI will prove the concept scalability by constructing and validating each step at TRL 5. The technical work packages focusing on the development of the efficient CO2 bioconversion to the added value organic acids and on their validation in a real environment are surrounded with work packages which provide an umbrella for the technology development by dealing with sustainability and circularity issues, the exploitation roadmaps and the business models, and also the potential regulatory issues and policy making, the communication dissemination of VIVALDI's outcomes and the social acceptance. VIVALDI is a very good demonstration of the importance of EU funding for research and innovation actions, developing this kind of breakthrough technologies for the CO2 conversion into added value chemicals, as well as for the creation of new business models and value chains in the CO2 utilization sector, as this kind of comprehensive approach ensures that our concept is valid. And this would not be possible without having the leading groups from the different fields on board. So in VIVALDI, we have 16 partners from all over Europe, including several industrial partners and technology developers, but also end users and knowledge hubs. The industrial partners are Sunpine, which is a biorefinery in Sweden, which utilizes tall oil from pulp and paper industry as the feedstock. Dam is a very well-known brewery founded here in Barcelona. BioAgra produces bioethanol from corn in Poland. And Novamont is a biorefinery in Italy, focusing on biochemicals and biomaterials. Luleå University of Technology from Sweden is our expert on CO2 capture and purification. And Vito from Belgium, UFZ from Germany, and Avantium from the Netherlands are focusing on the electrocatalysis. LATAT, together with UAB, are responsible for the bioelectrochemical nutrient recovery. The bioreactors will be operated at UAB and at Boku from Austria. Processium from France will be focusing on the downstream processing of the produced organic acids, and end users are Novamont and Nutrition Sciences from Belgium. The sustainability and circularity assessments will be done by Beta from the University of Vic, and the market exploitation will be assessed by IL from the Netherlands. CO2 Value Europe is coordinating our dissemination and communication, and the coordinator of the whole project is UAB. This VIVALDI's concept is not aimed to be exclusive, and the aim is also to boost the cooperation within strategic partners, such as major CO2 emitters, technology adapters, and end users of bio-based products. We also aim to raise awareness among all societal actors, including also policymakers, on the need of a CO2-based industrial sector to fight the climate change. To summarize, our main objectives are to develop, upscale, and validate the conversion of raw CO2 emissions to methanol and formic acid at biocompatible conditions, as well as to develop and validate the efficient yeast-based fermentation process for the conversion of CO2, methanol, and formic acid into added value organics. We are going to advance the circularity of bio-based industries by developing a new bioelectrochemical process to recover nutrients from industrial wastewaters. and design and validate the downstream processes to ensure that we obtain high efficiency and reach the end users' specifications. We are also going to demonstrate the technical and economic feasibility of integrating the VIVALDI concept in existing bio-based industries. We're going to ensure that the VIVALDI's solutions will have a positive impact from an environmental, economic, and social point of view, and to identify market opportunities and regulation bottlenecks for the market adaptation of VIVALDI solutions and products. We also aim to raise awareness on the role of a CO2-based industry in climate change mitigation, and of course, disseminate the knowledge generated from the VIVALDI project. You can find more information about VIVALDI on our website, vivaldi-h2020.eu, and on our social media. But if you'd like to hear more, or if you have any questions, you're very welcome to contact me as well. Thank you very much for your attention.
Thank you very much, Mira. That's a perfect example of what a research and innovation action is about, and how to bring technologies from TRL 3 to 4 to TRL 5 and prove their technical feasibility. We do have a couple of minutes for questions, but there hasn't been any on the chat. So let me remind everyone, any kind of questions you have, do put them on the chat or the Q&A, and we'll try to answer them during the workshop. If this is not possible, we will take them up and come to you later with a response. So don't hesitate to do this. The presentations will be available after, let's say within a week, I would say, and so will be the recording. So don't worry about that. So if there's no questions, and I see one question now from Angel Gaviero. Which part of the process cycle do you reckon could be the bottleneck until to address scalability?
So the novelty in VIVALDI is that we are trying to integrate all of these different technologies, the electrochemical reduction of CO2, the bioelectrochemical recovery of nutrients, and the fermentation. And I believe the bottleneck could be to finding the optimal conditions where we can make, or where we can have all of these steps working at their optimal efficiency. And this is something that we are really putting focus also in this VIVALDI project. So as all of these technologies are still at the very low TRL, more or less on the TRL 3, we really aim to really put focus also on that we can really bring the technology to higher TRL during this project.
Okay. Thank you, Mira. I don't see any other questions, so let me thank you again, Mira, and then I will go directly to Eric van Dijk from TNO, coordinator of Initiate, and he will explain what happens in a project that is at a little bit higher TRL, so an innovation action. So Eric, the floor is yours.
Okay, thank you very much, Anastasios. First, like to say thank you to CO2 Value Europe for giving me the opportunity to present the Initiate project. So let me share my screen. Okay, you should be able to see the presentation now in presentation mode. If that's not the case, then please let me know.
It's not yet in presentation mode for me, at least. So yeah, now it is.
Ah, okay, thanks.
Thank you.
Okay, so my name is Eric van Dijk. I work at TNO, and TNO is coordinating this project, the Initiate project. So in this presentation, I will highlight the concept of the project, but also very importantly the route towards this project, because as you can imagine, there's a whole development going before this. So the concept and the vision of the Initiate project is to demonstrate the industrial symbiosis between the iron and steel sector and the ammonia and urea production. So linking the steel sector with the chemical sector by transforming the residual steel gases into feedstock for ammonia production, urea production, and thus presenting indeed a route towards CO2 valorization. So what we're doing is transforming a waste gas basically from the iron and steel into a feedstock for chemical industry, using the caloric value of this gas and also using the CO2 that's in there. So the vision of the project is that by the end of the project we should have created a bankable case for a first commercial size demonstrator on the basis of BOF gas. And I will go to the technology behind it in a minute. So we want to, within the project, we want to take all the steps that are required to develop this first of a kind plant that should be built following this project. And important steps in reaching the readiness level for the first of a kind plant is that we have to demonstrate the concept. So that's part of the Initiate project. So we will build a pilot plant in the north of Sweden next to the SSAB steel plant, where we will take in the BOF gas, transform it into a stream that's suitable for ammonia production, and demonstrate the ammonia production as well. We will not demonstrate the urea production because if you have ammonia, the step towards urea is proven technology. So that's on the technology side, and based on this piloting, of course, there's techno-economic analysis, life cycle analysis, and business analysis. And next to that, for the first of a kind plant, the identification of the site where this technology could be rolled out is a very important step. So ideally, you will find a site where the iron and steel sector is very close to the chemical industries, and particularly the ammonia industry. Next important step is to create the business plan, to validate the business plan, but also to get all the licensing and permitting agreements into place. So a little bit on the concept of Initiate. What you see here are two schematic overviews of the iron and steel industry on the left-hand side, and the ammonia and urea production on the right-hand side. So on the left-hand side, you have the different steps going from iron ore to steel, where in these different steps, different caloric gases are produced. And these gases are used internally for heating purposes, and the surplus of these gases is normally sent to a power plant for electricity generation. And that's where about 50% of the CO2 emissions from a steel plant come from this power plant. On the right-hand side, there's a schematic of ammonia and urea production. So taking natural gas as feedstock, you reform it, you clean it up by removing the CO2. And then with the nitrogen-hydrogen mixture, you can make ammonia, and by reusing part of the CO2, you can make urea. So the Initiate concept is all about linking these two industries, and we do that by means of using the BOF gas. Because the BOF gas has a very nice characteristic that if you do decarbonization of this stream, that the hydrogen-nitrogen ratio is in the correct range for ammonia production. So you don't need to tune this gas composition a lot. You need to do some tuning, but not a lot. So what we want to demonstrate in this concept is that you can use BOF gas, use a novel CO2 separation technology called separation enhanced radical shift, or CWEX, that will remove the CO2 and make the suitable hydrogen-nitrogen mixture for ammonia production. which can then be combined with part of the CO2 that you remove to make urea. So this is the concept of the technology. But it's very important to highlight that the concept was demonstrated in a pre-project. So the successor of Initiate, which is the VIVALDI project. This was a project that's basically a desktop study to demonstrate, to analyze the feasibility, but also to focus on the consortium building for the follow-up project Initiate. And this project was financed by the Dutch National Top Sector Energy project that strives to link.
Eric, sorry to interrupt. There's probably something wrong with your microphone because it goes out and on every now and then. So I'm not sure if you can do something about it, but we can still hear you, but it feels that it's coming on and off.
Oh, okay. I'm sorry for that. I don't think I can do a lot about that.
Okay. Anyways, we can still hear you.
Yeah, okay. I'll try to speak then a little bit slower and more clearly. So the Initiate concept was studied in the pre-study above the urea. And the results of this study span quite the whole range of characteristics that you have to demonstrate. So in this study, we demonstrated the technical feasibility, but also the economic feasibility. And actually, we had calculated a positive business case for using this concept to make urea derivatives, which basically means that the capture technology, where you have a surplus of CO2 here, is paid by the sale of urea. And we had an initial identification of potential sites within Europe. Next to that, the environmental benefits were demonstrated in this desktop study, and that's shown on the right-hand side in this graph, where you have the CO2 emissions of the reference cases. So that's the separate steel plant and the ammonia plant. If you apply the Initiate concept, you already save 70% of CO2 emissions because you use the CO2 from the above gas. And if you combine that with the potential to store the surplus of CO2, you even go towards a 70% reduction in CO2 emissions. So this was a very important study that was the basis of the Initiate project. And very importantly, the consortium was already built in this pre-project, and almost all the partners of this pre-project also are part of Initiate. And this consortium really spans the whole value chain from material and equipment suppliers, such as TNO, providing equipment for the pilot plant, NextChem dealing with the ammonia section of the pilot plant, and Schwerin in the north of Sweden that provides the site for the pilot plant to be built. And we have two material suppliers, Kitscha Chemicals for the solvent, the reactive solvent that we use in our CX technology, and Johnson Matthey that provides the catalyst for the different steps. So next to material and equipment suppliers, there's technology licensors in the project. So that's TNO again for the CX technology, and Stami Carbon and NextChem for the ammonia and urea technology. Then there's end users in the project. So the largest steel company in the world, ArcelorMittal, and SSAB in the north of Sweden. And there's knowledge supports from universities, but also CO2 Value Europe, dealing with dissemination and also all the techno-economics and the LCA analysis that are the basis for the business case. So we have a 4.5-year project started in November 2020, and we'll continue to April 25. It's a 21.3 million euro EU-funded project under the flag of Spire in Horizon 2020. So some words on the route towards Initiate, because you can imagine this project doesn't come out of the blue. As I mentioned, the concept was demonstrated in a Dutch national project, and the key technology in here, which is desorption technology, that is a TNO development which has been pursued for quite some time already through multiple national and EU funded projects, and also some business-to-business projects. So on this graph, you see a typical TRL plot where you start with an idea and you end up with a commercial process. So we have been able for this technology to find funding opportunities for the different TRL levels that we were at that time. These are Kitscha was a European project where the idea was the initial idea was developed further. Then we had two national programs on carbon capture, CATO and CATO2, which helped the technology really towards the TRL 5 together with Dutch national project CAPTER. Then we had a very important EU sponsored project CESAR, where we went. We were ready to go towards the TRL 6, and the TRL 6 was demonstrated in the Stepwise project and the FRESME project. And currently we are stepping the technology up towards TRL 7 in Initiate. And next level would be TRL 8. Here on the right hand side, you see a typical graph for the cumulative amount that has been invested in this technology to get to the point where we are currently, and also the percentage of the contribution of third parties. So initially, when you have an idea, there's little money involved still, and it's all there's little subsidy also to work out an idea. But we were able to very quickly ramp up the contribution of third parties, so subsidy sponsored projects. And this is really key in the development of these kind of technologies. So we were able to go towards TRL 7 and later towards TRL 8 by indeed having a consistent funding opportunities. Because it takes time, it takes money to build such a technology out from an idea. Characteristically, the application for these different projects, they did change indeed somewhat. So some were focused on hydrogen production, some on the decarbonization of the power industry. But very importantly, they all had the same focus really about the technology development. So what's the current status of Initiate? We are currently in month 18 of the project. So we are in the first period of reporting now. And some highlights to show you is that in the detailed, we are currently in the detailed engineering of our pilot and the procurement of the equipment. So the layout of the pilot and the functional materials have been defined. And also very importantly, the control architecture is in development. And that's, I specifically mentioned this because the BOF process is a batch-wise process, which we have to turn into a continuous stream for an ammonia reactor. So here you see some dynamics of the feed gas, and for the ammonia you want to have a feed with continuous composition. So this is one of the challenges in the project. For that we also do multi-scale modeling. So dynamic modeling and plant control. And these models are developed in an early stage so that they can be implemented in the pilot. And of course, techno-economics and life cycle assessment is part of the project, and the basis of these two studies have been established in these first 18 months. Then on the commercial implementation plan, the business modeling basics have been established. And the site location investigations is continuously ongoing action to be ready for the first of a kind plant. So Initiate in a nutshell, 21 million subsidy project to demonstrate industrial symbiosis. So demonstrating the reliability of the concept so that it's ready for commercialization, and that we do by demonstrating continuous production of ammonia from steel gases in our pilot plant, and based on the modeling and the results from the testing, we should be able to confirm the business case so that we're ready for the rollout for the first of a kind plant. And this again is the consortium, and also important to mention our external advisory board consisting of two ammonia producers and 2 organizations active in the steel industry. So with this, I would like to thank you for your attention, and here is also indicated the website, so please visit our website to read more about the project. So thank you very much.
Thank you, Eric. A very clear example of how consistent funding can bring you higher up the TRL scale, and that projects that are proving technological viability and economic potential that need to be able to get to find opportunities for further funding instruments. I have one question for you about the economics of the urea business case. The positive economics that you showed, do they include the CO2 storage? So the scenario that yields 70% greenhouse gas savings from the economics, from the positive economics, is the CO2 storage also included there?
This initial case was without the CO2 storage.
Okay.
Yeah. So that's, but still without CO2 storage, the concept does save you on CO2 emissions by 70%, because you use your resources much more efficiently.
Yeah. Okay, thank you. And you, in the chat, you will see the websites of the 2 projects that you've here today. So any kind of questions, please reach out to the coordinators, to Vivaldi, and initiate to Mira and Eric. Yeah, I think we're very well in time. We still have a couple of minutes, but I don't see any other question coming up. If there is, then we will try to respond directly in the chat or in the Q&A. So thank you, Eric. Thank you, Mira, again. And we can move on to the second part of this webinar, still staying with Horizon Europe, but on the third pillar of Innovative Europe. And we will hear about the European Innovation Council, so an instrument linking R&I and entrepreneuriat. And I will give the floor to Francesco Matteucci from the EISMEA Executive Agency to share his screen and to take the floor to explain what the EIC is all about.
Thank you, Anastasios. Can you hear me and see my screen?
I can hear you. I can see your screen. Yeah.
Good morning to everybody. I'm Francesco Matteucci. Once again, thanks to CO2 Value Europe for this opportunity to present our agency and what we are doing on CCU side. Just, I will start saying why we existed within Pillar 3, and I will just shortly introduce you the funding scheme, then explaining what does it mean, the EIC hands-on or proactive management approach, then showing you some opportunities inside our work program 2022 for the EIC, and then some numbers that my colleagues kindly taken from some databases on CCU. And eventually, I will try to stay within the 50 minutes, also show you 3 examples of projects funded by EIC in the CCU field. So just to shortly go where Anastasios already said, EIC is part of the Pillar 3 of Innovative, so Innovative Europe, and it has been set up because, Europe, many of you already know this term, is this European paradox that means that we need somehow to help the projects to exploit their research results. This has been a need that has been understood and found out by the many numbers set up in the last, Horizon 2020. And so since the last part of Horizon 2020, there has been the need to set up what we like to call one-stop shop, agency for helping the ideas, the deep tech ideas to grow, to find the right way to exploit the research result. And so that has been the pilot of EIC, of European Innovation Council, that became an agency, fully fledged agency, the 1st of April 2021. EIC is part of the agency EISMEA, so European Innovation Council Small Medium Enterprises Executive Agency, and EIC has got the ambition, really, as you can see, through this 3 funding scheme, to help to nurture the ideas from its beginning, so from what we call technology development. So normally European Commission, many of you know the scale TRL, so technology readiness level. We start from very low TRL within the Pathfinder project. The characteristic of EIC, as I said before, is to help through the whole innovation journey, so from very low TRL to the high TRL. And going back, to the idea of the EIC, the idea is that we are the only agency that is able to do both policy and implementation. Policy means that we write our yearly work program, and implementation means that we work with the projects, not only monitoring them, but I will show you also this new way of having an hands-on approach, so working with the projects content-wise. So just to coming back to the ideas, just to show you some characteristics of these 3 funding schemes. You can get all the details concerning, the procedure to apply, the procedure for the evaluation within the EIC Work Program 2022 that has been published some week ago. If you simply Google EIC WP 2022, you find all the details. But just to shortly say that EIC mainly invests in the so-called deep tech. That means that the science-based approach, the science-based multidisciplinary projects, where you need to have the development of the technology when you work inside what is normally called an ecosystemic approach. So working with the real open innovation, so being able to share experiences, knowledge. These are part of the deep tech definition. But what is most important is that deep tech, in our sense, means to solve problems. So EIC tries to fund projects that has got the ambition to solve problems, normally through high risk technology. So the technology that needs a lot of money, a lot of know-how to be scaled up. And so normally it is where the risk is so high that there is a need to start with the money or to crowdfund money from a European Commission. So Pathfinder goes from very low TRL, what we say advanced research on breakthrough game-changing technologies. And then so the end of the Pathfinder is to reach the proof of principle. And then there is a transition. Pathfinder and transition are open to partnership, to all the kind of partnership Pathfinder, while transition is limited to the being part of the partnership of one partner that has been a winner in the last 24 months of a project coming from the Pathfinder or Future Emerging Technologies program, or from ERC proof of concept. So this is the limit of the transition in terms of the eligibility. So one partner has to be winner, as I said before, and transition brings this technology, from the proof of principle, so from the lab tested technology to the prototype. So to the testing the prototype in the relevant environmental conditions. So if Pathfinder should end at TRL 3, transitions should start from TRL 3 and bring it to TRL 5 and 6. And then there is the mono-beneficiary scaling up call funding scheme that is the accelerator. So accelerator wants to fund no partnership, but mono-beneficiary. The mono-beneficiary eligibility criteria is that it has to be a small, medium enterprises that has to start with the technology that has already been tested at TRL 5 or 6. So prototype in relevant environmental condition. With accelerator, we want to scale it up close to the market. Pathfinder Transition gives grant accelerator give grants, but also equity, because European Commission put in place the first venture capitalist fund, EIC fund. So another characteristic common to all the three calls is the identification of open calls, so no topic prescription. But here we go inside the second part, as I said before, EIC does policy and implementation, in part linked to the implementation, so working with the project. There are the challenge-based calls. What are challenge-based calls? Are challenges where all the project has to apply to overcome these challenges. And once these projects are approved inside the challenges, the characteristic is that they have to go on, they are selected, also sharing some components. The difference, so when we work with the challenges call is that there is a challenge, and that the second phase of the selection is linked to the concept of portfolio, so a targeted approach around the challenge, but with a shared component of all the projects, so to facilitate the uptake, the overcoming of the challenge, and the collaboration between the different projects. This is going through, as I said before, the second part of characteristic of EIC, that is the part linked to the hands-on, to the content-wise approach. This content-wise approach is linked to the program manager office. Together with Professor Marco Antonio Pantaleo, I am the program manager on green technology. I am more focused on materials for energy and environmental sustainability, while Marco Antonio is more linked and works more on the energy system. But together we work for the development of technologies for energy as well as environmental sustainability. And what we do, we mainly do two kinds of jobs. The first one is identify emerging challenges. So we are, as program manager, together with the other 6 program managers, 2 of them are in the health, 1 in biotech, 1 in medtech, and the 4 new program managers that arrived 1 month ago, 1 is on on quantum technologies, 1 on space, 1 on food and sustainable agriculture, and 1 on buildings and robotics. So what we do is we identify yearly, after a long discussion with all the experts, so we are continuously discussing with scientists, entrepreneurs, venture capitalists, managers, which may be the challenges where it has sense to push for 30 million overall budget. What does it mean, more or less 30 million? It means that in each challenge, it can be Pathfinder challenge, transition challenge, or accelerator, more or less, we will fund in between 6 to 9, 10 projects or companies that then will work together with this portfolio approach. So the first role is to identify, as written here, critical thematic areas after a long process of study that is never ending. It goes on year by year, and then we have to be filtered our proposal by the program committee and by European Commission. When they are approved, then the second step for us is to write the challenge guide that is, only in the case of Pathfinder, a detailed assessment of what we would like to get from the proposal to overcome the challenge. So this is the first part of the merging. And then the second part is what we like to call the hands-on approach. What we do, we categorize the projects. I will show you a first categorization. We try to make them work together around the theme. So we want project to help, and we work for the project to help them scientifically as well as business-wise. So just to show you an example, these are the identification, the categorization of the thematic portfolios within Pathfinder and Transition. You can see many projects, many topics. Consider that here in the projects more or less ongoing, there are 70, 80 projects, and these are in between Pathfinder and Transition. Then obviously in the first part, to give you an example, inside the renewable hydrogen, you can see we subdivided the projects in production, storage of hydrogen, and this year, inside this part, starting from September, there will be the first 7 projects funded within the first Pathfinder Challenge call that was set up in the EIC Work Program 2021, and it was on green or renewable hydrogen production technology. And so challenge projects will work within the thematic challenge portfolio of renewable hydrogen. And so these are other classification of the accelerators of the small, medium enterprises. And you can see that there are some coincidences of titles with the Pathfinder and Transition, but in the accelerator, being companies and being closer to the market, we work hands-on in that with a little bit different approach. So in the case of Pathfinder and Transition, we work also on the scientific approach. On accelerator, we try also to work mainly on the business. on both parts, Pathfinder Transition Accelerator, we work on the innovation journey. So we really try to link with stakeholders relevant for the acceleration of the market uptake of the technology, or in the case of Pathfinder and Transition, to the accelerator going in the direction of the prototype. We help them connecting wherever it is necessary with crowding in more investors. I said before, we can give equity, but the aim of the equity of the EIC fund is to crowd in more private investors, showing them the reliability of the evaluation process of European Commission. And so another aspect of this hands-on approach is the possibility of all the projects at a different level to get different BAS. BAS for us are business acceleration services. So the different projects, when funded by EIC, can have access to improvement of their skills, so somehow a certain type of training, but also help them to link to new business partners or to improve the stakeholder engagement with already ongoing but not successfully stakeholder engagement actions, as well as helping scaling up their technology. So this is the basis of the EIC approach. Now I will show you which are the opportunities for the CCU community to work with the EIC. And so just to show, there is a Pathfinder challenge call that we will write the challenge guide and will be published in the next 3-4 weeks. The deadline is in October. I don't want you to say dates because I don't exactly remember, but as I said before, in the work program, you can find everything. And here you see that this challenge is exactly in the side of CCU as well as nitrogen management and valorization. That means we will get most probably 3 kind of projects, very low TRL, one part on CCU, one part on nitrogen cycle, but we would also love to have projects that try to combine CO2 with nitrogen. So this is, where is the difference, you can ask, between our proposal and the proposal coming from Pillar 2? In this case, we are at very low TRL, and the second part is that we want the project to work together, as I said before, with this portfolio approach to overcome the challenge. There is also another Pathfinder on mid-long-term system integrated energy storage, where there is the possibility also here to work in the direction of CCU, part of this longer-term storage. Then there is, as I said before, for this type of calls, there will be the Pathfinder challenge guide, where we, as program manager, will write details on what it has to be done. There is also the opportunity to apply to the transition challenge. This year, the transition challenge is process and system integration of clean energy technologies, and there is a part also here I put in bold, in renewable fuels. So also here, projects coming from FET, Pathfinder or ERC funded projects can apply to this call, with the possibility, also here, there is a possibility for the CCU project. The same way for the EIC Accelerator, if you are a company, a small, medium enterprises, you have high impact innovation, your technology is a risk funding, and you are within the big areas, I said before, of deep tech, then you can apply for the Accelerator Open, but there is also Accelerator Challenge. And inside the challenge, technologies fit for 55, you see there is the decarbonization of hard-to-abate industries, and also here there is opportunity to participate as a CC with your CCU technology, with your small, medium enterprises. So just to show you some numbers, how we identify our challenges, we study papers, patents, we speak with people, but we also study database. In this case, we can see, I don't need to tell you because you are expert on CCU, we see that it's a big market trend from this data, and we can see here which are the challenges that has to be overcome for the market uptake. There is the necessity, we saw examples coming from RIA as well as from innovation action to create a more commercially viable process. IPCC report showed us that CCU is really important, so there is the need to decrease as well all the part of the CCU, the capture as well as the utilization. There is the need to set up, as we saw from the RIA at the beginning, from the project VIVALDI, the idea of really the circular economy, trying to complete what the CO2 needs once it is, reduced, for example, to CO2, it can be combined from nitrogen. Where can we take the nitrogen? From wastewater treatment. Okay, so we can combine these 2 building blocks to set up new materials, new chemicals, and this is an opportunity to make really the CCU become a really added value for the overall community worldwide. And so we see that the investment in the last years has been continuously increasing from the venture capitalist world within the CCU technology. We can see in this categorization of clean tech the identification of CCU within the field of advanced materials, within the field of chemicals or fuels, and so on. But let us look for a second some data. We see here the overall budget invested from 2018 to 2022 has been approximately of 5 billion within the CCU, and we can see that for the companies, for the European companies, we see that approximately 1/3 of it has been invested, and we see here in the companies Europe, the subdivision, a big amount of money from Switzerland, mainly coming from Climeworks, but we see a different identification of companies around the whole value chain of CCU inside Europe. And just to give you some more data, we see here some examples of the investment done in European companies. So the huge amount of money invested in Climeworks, Avantium, Electrocare, Ineratec, and other companies. And here we see that EIC also helped some of these companies. And so these are 3 projects, 3 examples. 2 are within Accelerator and 1 is within Pathfinder, that has been funded by EIC with grant, and that has been helped by EIC to scale up their technology. So in one case within Electrocare, we see the power to gas through biomethanation, the development somehow of the biological part and the scaling up of this by Electrocare. In the case of Ineratec, we see their ability, attempt to scale up their technology power to gas by chemical methanation and synthesizing closer to the utility or to the where you can get the CO2 or the hydrogen as input. In the case of Ineratec, we are speaking about containerized solution. In the case of Electrocare, we're speaking about biomethanation with different markets. The technology are different, and our job has been and will be to help them scaling up their technologies with all the help we can give them from the scientific, business, but most important, innovation point of view. In the case of Madonna, this has been a future emerging technologies funded, ended a few months ago, and this project wanted to combine the capability of microbes to absorb CO2 to capture and eventually not only CO2 but also nitrogen, and to convert it potentially in different products, some of them also for the building industry. So setting up bricks that are able to absorb CO2 and that can convert it for different using and use the CO2 as a building block for the development. Thank you very much. I use 3 minutes more, but I'm more than happy to answer to the question. Thank you very much.
Thank you, Francesco. Very rich presentation, showing the importance of combining these 2 worlds of R&I and innovation and entrepreneuriat. One question from the audience is, can you comment a little bit on the difference or the collaboration between the EIC and the EIT, so the knowledge and innovation communities of the European Institute for Innovation and Technology, because they're both on the same pillar. So what kind of a difference is there? Or
the difference is that we are a funding agency inside European Commission that wants to promote the the goals of the project, the objective of the project through our work program, yearly work program. We mainly work on the content of the projects, not dealing, in our case, as program manager, we work with the community, but we do not have the ambition to set up communities, okay? The other side, EIT works in different thematic areas that are set up by knowledge innovation communities, by the KICs. So these thematic areas try to set up to improve the communities and do not have calls as we have. So they work more on different type of calls, working also on the building of the communities, of the setting up of new communities, and on the training. While EIC is more on the implementation and the scaling up of the technologies. Let me say that there are some overlaps, but that's good, because there are projects that are funded by EIC as well as by KICs, vice versa. And this is important because we try to give a different approach as EIC and EIT, but obviously we work together. There is an agreement of collaboration between EIC and EIT.
Thank you for that. And final question, can you apply for a transition project if you have not had a Pathfinder project?
No, you need to have one of the partners that want to scale up its technology, and this technology has been previously funded by FET, Pathfinder, or ERC proof of concept. So you can apply, but within your partnership where you apply, there has to be one partner that won a FET, Pathfinder, or ERC proof of concept, and most probably you will need, obviously, to show and to work on the scaling up of the technology that was funded by FET, Pathfinder, or ERC proof of concept. So the answer is yes, but. The but is you need one of the partners to want it to scale up this technology already funded.
Okay. There's another interesting question, but I will put it on the chat because I will move on so that we keep time. So Francesco, if you can take a look in the chat later and maybe comment on that. I haven't put it yet, but I will. Thank you very much, Francesco. And now we will move on. We'll go out of the scope of Horizon Europe, but still following the TRL scale. And I will give the floor to Roxana Chesoi and Daniel Kitscha from DG CLIMA to present the Innovation Fund.
Good morning.
Good morning, Roxana.
I think that everyone hears me. Yes, in fact, I was supposed to share the presentation with my colleague Daniel, but I think that he has some connection problems. So I will be starting, and if he joins later, then we share like that. Next slide, please. So just to give an idea of the overall policy challenges that us in DG Climate Action are facing. As you might probably know, I'm part of this small team in DG CLIMA, who is dealing with the Innovation Fund, and we and also, as Anastasios said in the beginning, there is a rich policy context around climate neutrality, Fit for 55, and so on. So this slide just shows you, for example, where industry stands today and where we are supposed to reach, and the Innovation Fund should contribute, of course, to that neutrality. Next slide. Here we have put for you a sort of expose of what funding programs CCU technologies can benefit from, but not only, just to be able to understand where the Innovation Fund is placed in this map of different funding programs. So practically, you have heard about Horizon, you have heard about EIC. We also have the LIFE program, and CLIMA is also part in that. And then we arrive to the Innovation Fund, where we aim at the first of a kind upscaling and commercialization. On technology readiness levels, TRLs, that most of you are very used to hearing about, we aim at high-end TRLs, but there is no really, how to say, a target. So even technologies with lower TRL can apply for the Innovation Fund if that particular technology can reach TRL 9 faster, and the commercialization, it really, so do not see it as an as an impediment. And later on, projects, of course, there is InvestEU, CEF for larger investments. Next slide. So the Innovation Fund is practically, as I said, scaling up, trying to contribute to scaling up clean tech. CCU is part of this, so carbon capture and utilization technologies are part of this. You see this right corner category. Apart from that, we target renewable energies, including manufacturing plants of components, energy-intensive industries, including substitute products, so and energy storage. Next slide. This is just an overview of the key features of the Innovation Fund. First of all, the volume is 38 billion. That's why it's one of the largest programs in the world. Most of it, I would say, will go to grants. So until 2030, there will be regular calls every year. So, but also other types of support will be developed later on, like this competitive bidding and so on. We support the additional capital and operating costs calculated on a scale of up to 10 years for large-scale projects, whereas the support is 60% of CapEx for small-scale projects. And small-scale projects are the ones with total investment costs lower than 7.5 million euro. What is interesting about the Innovation Fund is that we grant up to 40% at financial close. Financial close is the moment where practically all the different investment sources have been confirmed, contracts have been put in place in order to start construction. So if you have reached this point, that's really a very important milestone for us. We give you already up to 40% so that you can have some cash flow for the construction. Now, another of our particularities is that we are financed from the EU emissions trading system. So that's why practically the volume of the Innovation Fund depends on the carbon price. And as you all might know, the carbon price has been increasing steadily over the past years, months. And therefore the available amount is increasing as well. And but also the EU emission trading system is currently under revision. So we might also have some changes for the Innovation Fund. As I said, we are expecting annual calls for large scale and small scale projects. And then another particularity of the fund is that we fund the avoided greenhouse gas emissions. So we pay the rest of the grant if you prove that you have avoided the greenhouse gas emissions that were planned to avoid when you submitted your application. There is a detailed methodology on calculating greenhouse gas emissions specifically for the fund. Compared to the Horizon Europe, we accept single applicants or consortium, but we also encourage very much synergy. So I would really like to see in a few years projects like VIVALDI or Initiate coming to get further funding from the Innovation Fund. And also there is another dimension. Rejected projects could get project development assistance provided by the European Investment Bank. And therefore, and this PDA is really targeted on the project and on the Innovation Fund award criteria and maturity, project maturity. So such projects can easily reapply in further calls. The next slide. Yeah, maybe here we reach the most interesting part of what I wanted to say today. We did receive a lot of applications in the first calls. The fund was very much oversubscribed. Even if the second large-scale call might seem to be, the number of applications has decreased. It was still oversubscribed 8 times in terms of budget. And here are the CCU technology pathways identified in the application. So practically, the dark green would be the first call for large-scale projects, the middle, the second large-scale call, and the yellow would be the small-scale call. what is interesting here, that most of the CO2 projects that apply for the Innovation Fund use the CO2 for fuels. Then we have practically almost the same, I would say, more or less, for different chemicals. Then on building materials, and this includes also mineralization, for example, practically making building materials through mineralization. And also there is a part on CO2 storage, because in the end, without storage, we might not be able to reach this climate neutrality in 2050. Next slide. Here, which just an overview of the many innovation fund sectors where we have received CCU projects. There is no particular order. It's just to prove that CCU which applied to the innovation fund really was in different types of industries and categories and sectors. Next slide. Now here, I wanted to give an overview for whoever is not aware, but of course, all these details are in each call and call text, and there might be differences in the future as well. But just a short overview how we do the selection and evaluation criteria. Practically, the evaluations are done by external evaluators, identified and hired by CINEA, our executive agency who's implementing the program. Then we get from CINEA, CLIMA gets from CINEA a list of pre-selected projects, and we consult member states, both on the awarded, the list of projects for receiving grant award, and afterwards on the projects that EIB shortlists for project development assistance. The award criteria are related to the innovation, the greenhouse gas emission avoidance, maturity, scalability, and cost efficiency, and I will go into more details in the next slide. Practically, as I said, the greenhouse gas emission avoidance is one of our most important criteria, and it's important that this calculation is done correctly in order to have to be able to correctly disperse also the grant afterwards. As I said, 60% of the grant is actually dependent on this verified greenhouse gas emission avoidance. On a degree of innovation, we assess the innovation beyond the state of the art, and only for large-scale projects, a contribution to policy objectives such as circularity that we heard about today earlier in the projects. The project maturity is assessed on 3 dimensions: the technical maturity, so practically everything that is related to the technology itself, whether it was demonstrated at pilot, at demo plant, and the TRL level, although not particularly evaluated. Operational maturity looks at the project implementation plan, if everything has been correctly planned, and also the team and the permitting and everything. I mean, you have to understand these are very big projects, so everything that relates to also to environment impact is important. And last but not least, I need to mention the financial maturity. This is, it seems, the most difficult sub-criteria for our projects. They need to demonstrate that they can potentially reach financial close within 4 years after the grant signature. But also there are other dimensions like the sources of funding, I mean the planned sources of funding, the business plan, the cash flow projections, all the revenue streams, and so on. So it's quite a complex criteria to prepare for and to evaluate. The scalability looks at the potential of the project to scale up at regional, sectoral, and economy-wide level, where the cost efficiency looks at practically the grant amount over the absolute greenhouse gas emission avoidance. Now with the small scale call, and in the future we will have a sub-criteria on the quality and credibility of the calculation of the relevant cost, because this sub-criteria was also analyzed under financial maturity, but following lessons learned, we decided to have it apart for more clarity. The next slide, please. And now I need to talk to you about the ongoing small-scale call, which was launched at the end of March and has a deadline in August. This is very important because for innovation, we will be assessing the innovation that goes beyond state of the art, actually in the country where the project is located as a reference point. This is important because if we have a green hydrogen project in Bulgaria, and it would be the first hydrogen project in Bulgaria, then that project might have a chance, provided that all the other award criteria are fulfilled. Also, what we learned from the previous call, actually the quality of the project that we received was a bit lower than for the large scale. So practically, there is a big chance of funding the projects that already reach above thresholds for all the award criteria. Last time we had 32 pre-selected projects out of 38. So we hope that also this time we will get enough good applications so that we have a good selection procedure for the small people. I see that my colleague Daniel has managed to join, so if he's ready, this was anyway the break of the presentation between us. So Daniel, please.
Thank you, Roxana, and apologies for being late. I had some trouble logging in. Indeed, I think you have a good picture now about what the Innovation Fund is, how it works, and how our applications are assessed, which is of course crucial. But also important, as Roxana just said, is the message that there is actually a call open just now. And in order to help you when you are preparing a project, to assess where you are on the preparation steps that need to be done before a successful application, we have a self-check questionnaire on the web. This is a tool that we offer to any interested applicants. It is focused on the small-scale projects in the sense that there are some improvement or sort of simplifications for small-scale projects, notably that sort of everything that we support is considered the CapEx. But it's important to see the self-questionnaire as a tool for you to see where are you with your project in view of the Innovation Fund. And so what we access, what you can access yourself is how does your project fit with the scope? So overall, the scope of what we can support under the Innovation Fund, and how ready is your project preparations for an application. And the result is that you will get a tailored feedback. This is an automated feedback, so there is sort of no confidentiality problems with this, which you will get based on sort of the rules that we apply to Innovation Fund calls. And with that, also links where you can read further into this. This is also quite useful for anyone who considers to apply to the Innovation Fund, because we always do detailed information webinars, which are recorded and are still on the web. So you will be pointed to this, where all the steps that Roxana just explained are explained in more detail, so that everyone who wants to do an application has a good idea of how it will be assessed. If we can go to the next slide. There is another form of support that we give to you as projects, and this is, yes, I will speed up. This is NER 300 financial advisory. There you can actually apply to get support to create sort of the financial framework of your project. Important to mention here is that it is limited in comparison to the Innovation Fund to renewable energy, carbon storage and use, and smart energy systems and energy storage types of projects. And important for today, if you do carbon usage, the project has to be linked to renewable energies. That's sort of a given there. Next slide, please. There is a possibility to apply to this. It has nothing to do directly with the Innovation Fund, in the sense you don't need to apply to the Innovation Fund. You can apply first to this advisory support, and then build on that basis your project for an application to the Innovation Fund. Next slide, please. Because not only is the small scale call still open, there will be a next call, also large scale call, still this year in autumn. The date we haven't announced yet, but the rhythm this year and then in the next years will be a large scale call in the autumn of the year, with a deadline for submission in spring of the following year, and then results in the autumn of that year. And a small scale call like now, opening in spring, deadline around sort of early autumn, and expected results then in the spring. The expected volumes are to be watched. Today there will be a communication. The Repower EU communication will be published by the Commission, and I invite you to have a look for Innovation Fund in this communication. This is our last slide. You find a lot more information on our websites, including the information webinars, which are taped, where you can inform yourself about the details of how to apply. Thank you very much, and I think our last slide is to be ready to answer any questions you might have.
Thank you, Roxana. Thank you, Daniel. I see already Roxana responding to some questions, so I won't have the time to ask the questions. So please do use the answering function, Roxana and Daniel, to answer to the questions that appear in the Q&A, and all the audience can see the responses. So indeed, a very important instrument, a very large instrument, and a very let's say impactful instrument for also for CCU technologies. So thank you, Roxana and Daniel, again. And I will jump directly to the Breakthrough Energy Catalyst team. I know it's very early in the US, so thank you very much, Nisha, for taking the time. So Nisha and the team of the Breakthrough Energy Catalyst will present another instrument that is also relevant for CCU technologies. So please, Nisha, you have the floor.
Great, thanks. My colleague Julia Renaud from Europe is also on, and she's going to kick the presentation off, and then I'll get into the details of the program. So Julia, are you on?
I am. Can everyone see me or hear me at least?
Yep. We can see you and hear you.
Okay, great. Good morning, everyone, and good morning, very early morning to you, Nisha, because you're calling out from the US. So my name is Julia Renaud. I'm based out of Paris, and I work for the Breakthrough Energy team based in Europe. For those, Nisha, maybe if you can go to the next slide. For those that are not familiar, let me just say a few words about Breakthrough Energy. It was established in 2015 when Bill Gates and a coalition of private investors began to focus their collective resources to fight climate change. And as you can see here, Breakthrough Energy is a network of entities, initiatives, including investment funds and not-for-profit and philanthropic programs that I can speak briefly about. And all of this with the common efforts to drive an accelerated pathway towards the commercialization of these technologies that we most need to reach net zero, as well as in order to be able to bring down the costs of those technologies and solutions so that we can make them affordable to all. So as you can see here, Breakthrough Energy is organized to help address the gaps that exist at various stages of the technology innovation development. And the gap particularly that delays the time to market as well as the time to scale for these climate technologies. And we focused on the technologies that at scale have the potential to reduce greenhouse gas emissions by 0.5 gigaton of CO2 by 2050. So we're very much driven by the science and the technology assessments of what these different solutions can provide. Looking just from left to right, the Breakthrough Energy Fellows is solving for the funding gap that exists for early stage R&D by supporting research efforts. Then we have Breakthrough Energy Ventures and a partnership with the European Commission with a fund called Breakthrough Energy Ventures Europe, which solves for the fund that exists at the stage of company formation by investing initially in early equity rounds and supporting the capital needs of these climate technologies in order for them to reach scale. So it's patient capital of around up to 20 years. And we're speaking to you today about the Breakthrough Energy Catalyst program that's solving for the funding gap that exists for early stage technology projects. So here we're very focused on projects, and Nisha can speak to you more about the uniqueness of Breakthrough Energy Catalyst, because we provide a blended capital vehicle which combines grants as well as low-cost equity and the opportunity also to help secure offtake agreements. But I'll let Nisha speak more to the Catalyst program. Let me just point to the next slide, which speaks more to the partnership that we have with the European Commission and the EIB. So this was a partnership that was announced last June and formalized at the COP26. Here you see a picture in Glasgow. And this is a unique, from our perspective, a unique public-private partnership that's designed really to help scale and commercialize the critical climate technologies in Europe. And we're focusing on green hydrogen, long-duration energy storage, sustainable aviation fuels, and direct air capture. So all quite relevant, of course, to today's topic. Through the partnership, the EU, the EIB and the EC and Catalyst will invest up to $1 billion, or 884 million, to finance projects in Europe. And we provide matched funding. So both the EC and the Catalyst will provide matched grant funding, and then other forms of capital that we will provide. Now, just to say a few words here, this is really a program and a partnership that is here to complement and to be an additional source of financing and funding to all of the programs that you've heard earlier. So the EIC, Horizon Europe, the Innovation Fund, it's definitely not in competition, and Nisha can speak to more about that, but we're seeing this as part of the continuum of the offer to support these projects in Europe. And we're really hoping to accelerate the innovation cycle by bringing and supporting commercial scale projects. We're really also very much interested in looking at what are some innovative players, some innovative technologies, and how can those help reduce the green premiums and in future reduce greenhouse gas emissions. And finally, we're leveraging the best of all partners, and Nisha can speak more to the partners that we have with us in addition to the European Commission and the EIB. With that, let me pass on then to Nisha to explain the process and more in detail the Catalyst.
Thank you, Julia. And hello, everyone. Good morning. For those of you who don't know me, I am Nisha Patel. I'm part of the Breakthrough Energy Catalyst team, primarily supporting and leading the sourcing and selection efforts, so what we call requests for proposals. And I think Julia really kind of summarized Catalyst pretty well, but essentially what makes us very unique is that we're able to bring together a set of diverse stakeholders ranging from governments to companies, philanthropists, and individuals. And the main mechanism by which we support projects, and again, want to specify that we don't support companies from like a Series A, B, C perspective of funding. That is what our Breakthrough Energy Ventures arm does under the Breakthrough Energy umbrella. But what Catalyst is focused on is providing funding to projects at the special purpose vehicle level, but we're also open to other forms of structures depending on uniqueness of each project. But we deploy our capital in the form of grant and low cost equity. And there are other resources that we're also able to bring to the table, such as offtake agreements from our corporate partners. And these offtake agreements essentially are contracts for purchasing the clean product that are produced from these projects. So, for example, in direct air capture or CCUS, that would be the purchase of the carbon credit, for example. And then, like Julia mentioned, we are focused on 4 main technologies. And so we are planning on deploying our funding to projects that are focused on sustainable aviation production, long duration energy storage, direct air capture, and clean hydrogen production. And where CCUS comes into play is that with production of clean hydrogen and sustainable aviation fuel, quite often what we're seeing in projects is a component of CCUS to then capture any carbon that may be emitted as a result of those 2 products being produced. And so there are a lot of synergies for our program to support CCUS through those 2 particular avenues, as well as certain projects that we've seen for direct air capture are also using CCUS for certain portions of capturing the carbon, especially if other forms of energy are used for the heat component. There are 2 main mechanisms by which we measure success. One is our project's ability to reduce the green premium of the product. So the green premium is essentially the delta between the clean product and its fossil-based incumbent, and how that project can also continue reducing the green premium as a result of unlocking a set of future projects. On the other hand, we also measure success through the amount of emissions that are abated as a result of the deployment of a particular project. And then again, similar to the green premium, how that particular project can continue increased reductions as a result of unlocking future projects. So a little bit more about our stakeholders and the partners we're able to bring in. So one of the key things, one of the key partners that we bring in are governments who are able to provide policy foundation and low cost project capital. Then we are also able to bring in technology and project developers, such as some of you who have joined today, to supply the industry and scientific expertise to build these innovative projects. And lastly, we leverage and bring in corporates, investors, and philanthropists to provide that project capital and early market demand for the clean products through those offtake agreements that I spoke about in the last slide. And where Breakthrough Energy Catalyst comes in is the ability to bring all these stakeholders together in order to provide low-cost capital and resources needed to fill those critical funding gaps in an accelerated manner, and as a result, create new markets for these clean products. So far we've announced a set of partners, which you can see on the right, and we hope to continue growing that pool of partners in order to really maximize the available funding for these critical projects, and then hopefully continue the decarbonization goals or our decarbonization efforts. In terms of our RFP, or request for a proposal, which is essentially our funding opportunity, we launched one in the EU in mid-January. And this RFP is unique in the sense that it continues to remain open, even though there may be times of initial rounds or continued rounds. And so with this first launch, we had set an initial evaluation date of mid-May. So in fact, we received proposals last Friday. And these proposals or projects are seeking funding in the Q1 of 2023 timeframe. But if projects that weren't able to submit by the May 13th deadline, we are still going to be evaluating projects on a rolling basis. So some of you who are on the call today may have projects that you may be interested in submitting later this summer or in the fall timeframe. And our RFP process is designed to continue evaluating those projects on a rolling basis. But on the other hand, there also may be an opportunity for future rounds. And so we'll be announcing those rounds on our website as well as our social media posts. So those projects that did make it by the May 13th deadline will have about internally 90 days to complete those submissions. And then, I'm sorry, we will have Breakthrough Energy Catalyst has 90 days to evaluate those submissions. And then we will be inviting those projects that are down selected for presentation. Those projects that have successfully made it through the presentation round will be then invited for part 2 submission. However, there may be an opportunity to do both the presentation and part 2 in parallel. And then those that are successful from the part 2 submission and through that evaluation process will then receive a down selection notice. And these will be contingent selections where Breakthrough Energy Catalyst will then share the list of projects to the EIB for evaluation of funding under InvestEU. EIB will then confirm whether those projects are also eligible for InvestEU funding. And if they are, both the EIB and Breakthrough Energy Catalyst will conduct their independent due diligence processes as well as negotiations, and then end with any closing and funding. There are going to be synergies where EIB and Breakthrough Energy Catalyst will try to collaborate in order to streamline the process as efficiently as possible. But the intent is to have separate diligence processes. In terms of what Breakthrough Energy Catalyst uses to evaluate these projects, well, there are 5 main criteria. These are impact, development, financial, commercial, and technical. From an impact perspective, as I mentioned earlier in the presentation, we are looking for projects that can reduce that green premium and reduce and abate CO2 emissions, as well as understand whether this technology is scalable, not only from a size perspective, but also can it be deployed in different geographies. From a development perspective, we are looking at whether the project is ready and mature. It has gone through substantial development progress and hit certain milestones. We're looking at whether the project has the ability to deliver on what is outlined in its proposal, as well as the quality of the submission. From a financial perspective, we're going to look at whether the project is viable. One of the criteria we'll look at is investment size and how our funding could be catalytic. And then we'll also look at whether the project risks that have been outlined from a financial perspective can be underwritten. From a commercial perspective, we're looking at the quality and maturity of key contracts. So this could be feedstock supply, offtake agreements, as well as equipment procurement. And lastly, from a technical perspective, we want to see whether this technology is mature and has gone through at least the pilot stage, as well as any engineering details related to the project. And then diving in a little bit more on the eligibility criteria. So in general, regardless of the technology, we are looking for projects that are focused on one of the 4 techs. So clean hydrogen, direct air capture, sustainable aviation fuel, and long duration energy storage. But as I mentioned earlier, CCUS is a key component of clean hydrogen production as well as sustainable aviation fuel. So we would take that into consideration. We do want to see whether this technology has been proven at the pilot stage and can reduce CO2 emissions overall. And we do expect that these projects that do submit a proposal into our process have an expected operation date of 2030. But in the near term, we do have a preference that these projects are coming on at least by 2027. However, we are open to evaluating projects that are potentially later in the timeline. And lastly, as I mentioned, we are looking for projects that are moving on to that next stage from pilot to and demonstration to potentially pre-commercial or commercial stage. In terms of DAC or our carbon removal focus, we are looking at projects that are leveraging solid and liquid sorbent technologies as well as carbon mineralization. And then we are not looking at projects that are solely nature-based, so planting of trees or plants. And we will consider projects that include supporting infrastructure for carbon capture facilities, such as injection walls, or wells, CO2 utilization, as well as pipelines and transportation. So within this like supporting infrastructure theme, that is also applicable to clean hydrogen SAF, where CCUS would be considered. So with that, we would love to answer any questions that you may have. And if we're not able to get to any questions today, you are more than welcome to contact us at catalysteurp@breakthroughenergy.org. And we have a set of documents that are available on our webpage that describe our RFP process, as well as any answers to general FAQs. So with that, I think we might be at time, but I'll hand it back over.
We're perfect in time, Nisha and Julia. Thank you very much. I have one question and one question only, because we're almost done. We're 12 o'clock here. So the question is whether you know when the Breakthrough Energy Catalyst Fund will be available to apply for in Norway. And the person asking the question says that we received assistance from the EIB NER 300 program. And we have been informed that Norway is not eligible, which was also confirmed by Innovation Norway. So it seems that the BEC is not available in Norway. Is this going to change?
Maybe I can come in here if you'd like. So Norway is actually one of the countries where indeed the Catalyst program is absolutely eligible. So Norwegian projects can apply. Our understanding is for the EIB portion of funding, there's still, we don't know the latest, but we're discussions around whether or not Norway was a party to InvestEU, and that's then the condition to maybe receiving the EIB EC funding. But on the Catalyst side, absolutely, Norway is already included in this request for proposal. Okay, perfect. Thank you for that, Julia.
So I don't see any other question live, and we're at 12 o'clock, so perfectly on time. I'd like to thank all speakers from the Innovation Fund, from the EIC, from the Breakthrough Energy Catalyst. So thank you very much, giving an overview of important instruments for where CCU finds its place. And of course, these are instruments that are here to stay and to support CCU technologies go up the TRL scale. We as CO2 Value Europe, we do our best to bring together the stakeholders and provide them this information that will help them apply. We're part of the expert group of the Commission, for example, for the Innovation Fund. So we are regularly informing our stakeholders on that, and don't hesitate to reach out to us to see how we can help you in this process. So again, thank you all speakers for your contributions today. The material will be available within a week, and we are wishing you a very nice day.